Hello everyone, welcome to all. My name is Pradeep Bhandari. In this session, we'll have a close look at computer security and security services. Communication networks have opened the floodgates of information and enabled instant access to information anywhere, anytime, and in any format. But security, trust, privacy, malware, and increasing threats are still key issues of communication networks. Network and information security addresses these issues, but one should implement these solutions very diligently after studying every aspect of network. So the main objectives of this video lecture are understanding what computer security is, different computer security threats and countermeasures, different security services and security service mechanisms. So let's start our discussion with computer security. Computer security deals with the protection of computer system and information stored in the computer system from unauthorized access. Unprotected computer systems provide the attacker with too many opportunities for obtaining unauthorized access to the computer system. Even if there is a well-tuned firewall in front of the machine, it's hard to anticipate every way in which attacker may access the protected system. The main security concerns to the computer system are intruders, malicious programs, and vulnerabilities in operating systems and application software. Let's consider them one by one. Intruder is generally referred to as a hacker or cracker. There are three classes of intruders. These are masquerader. It is an individual who is not authorized to use the computer and who penetrates a system's access controls to exploit a legitimate user's account. Other type of intruder is misfeasor. It is a legitimate user who accesses data, programs or resources for which such access is not authorized, or who is authorized for such access but misuses his or her privileges. Most dangerous type of intruder is clandestine user. It is an individual who seizes supervisory control of the system and uses this control to evade auditing and access controls or to surpass audit collection. The second category of security concern is malicious programs. Perhaps the most sophisticated types of threats to computer system are presented by programs that exploit vulnerabilities in computing systems. In this context, we are concerned with application programs as well as utility programs such as editors and compilers. There are various types of malicious programs. First is backdoor. A backdoor, also known as a trapdoor, is a secret entry point into a program that allows someone who is aware of the backdoor to gain access without going through the usual security access procedures. Programmers have used backdoors legitimately for many years to debug and test programs. Next type of malicious program is virus. It is a program that attaches itself to a program and propagates copies of itself to other programs. Another is a worm, which is a program that propagates copies of itself to other computers. Next is logic bomb, which trigger action when specific condition occurs. Other type of malicious programs are Trojan horse, exploits, auto routers, spammer programs, flooder, etc., as shown on the screen. The third category of security concern is software and operating system vulnerabilities. A significant issue in computer security is the applications installed on the system. Of course, a computer system is typically useless without the applications and operating system components necessary for it to fulfill its function. At the same time, any software installed on a system may be exploited due to vulnerabilities in it. A configuration flaw or a coding error can provide the attacker with access to the underlying host, offering an internal landmass from which to conduct further attacks. For example, buffer overflow exploits against a vulnerable application can allow an attacker to execute privileged commands on the targeted system. Operating system and applications contain vulnerabilities that attackers can exploit. Even though some of these vulnerabilities might not have been discovered yet or have not been publicly announced. Now, to recapitulate, the three main categories of security concern are intruders, malicious programs, and vulnerabilities. To address these security concerns, there are various security mechanisms. First is password protection. The front line of defense against intruder is the password system. Virtually all multi-user systems require that a user provide not only a name or identifier, commonly known as ID, but also a password. The password serves to authenticate the ID of the individual logging on to the system. In turn, the ID provides security in the following ways. The ID determines whether the user is authorized to gain access to a system. In some systems, only those already having an ID on the system are allowed to gain access. The ID determines the privileges accorded to the user. A few users may have supervisory or super user status that enables them to read files and perform functions that are especially protected by the operating system. The ID is used in what is referred to as discretionary access control. For example, by listing the IDs of the other users, a user may grant permission to them to read files owned by that user. A strong password is recommended from security point of view. The most promising approach to improved password security is a proactive password checker. In this scheme, a user is allowed to select his or her own password. However, at the time of selection, the system checks to see if the password is allowable and if not, rejects it. Such checkers are based on the philosophy that with sufficient guidance from the system, user can select memorable password from a fairly large password space that are not likely to be guessed in a dictionary attack. Some of the rules which are normally used to enforce a strong password are to have password of more than some particular length and must be consisting of numeric and special characters. These rules could be enforced for strong passwords. Second security mechanism is antivirus software. Antivirus software is the most widespread mechanism for defending individual hosts against threats associated with malicious software or malware discussed before. Many established vendors such as Symantec, McAfee, Sophos, Trend Micro and F-Secure offer products that detect and in many cases eradicate malware from the system. This is accomplished by monitoring the local host's boot sector, memory and file system for signature of known instances of malware. Another detection mechanism that is often used in conjunction with the database of malware signatures monitor programs for behavior pattern frequently associated with malware. Properly deployed antivirus software can be very effective against malicious softwares. Using anti-rootkit against rootkit programs is also a good idea. Another security mechanism is host-based firewalls. Host-based firewalls are often referred to as personal firewalls because they aim to protect individual systems instead of whole networks. By using host-based firewalls, we can restrict what kind of traffic could leave and enter in computer systems. So these host-based firewalls are very effective in saving computer systems from threats and vulnerabilities. Some common and popular host-based firewalls include Zone Alarm, Tiny Firewall, Norton Personal Firewall and Windows Firewall. Another effective security mechanism is host-based intrusion detection. Host-based IDS products also exist primarily to detect and examine malicious activity at various stages of an attack, but they are optimized for monitoring individual hosts. Additionally, many host-based IDS products can be configured to integrate their findings, providing a unified view of multiple systems throughout the network. Some host-based IDS products also provide intrusion prevention capabilities, stopping attack before they can cause damage. Host hardening is another security mechanism which is used to counter software and hardware vulnerabilities. Host hardening involves protecting the computer system from known software and operating system vulnerabilities. Host hardening can be achieved by disabling and removing unnecessary programs, limiting access to data and configuration files, controlling user and user privileges by applying security updates and patches. To summarize, password protection is used to evade intruders or unauthorized users. Antivirus software, host-based firewall and IDS are used against malicious softwares, and host hardening is used against vulnerabilities of the softwares and hardwares. Now let us discuss security services. Standard X.800 defines a security service as a service provided by a protocol layer of communicating open systems, which ensures adequate security of the systems or of data transfers. Perhaps a clearer definition is found in RFC 2828, which provides the following definition: a processing or communication service that is provided by a system to give a specific kind of protection to system resources. Security services implement security policies and are implemented by security mechanisms. X.800 divides these services into 5 categories and 14 specific services as shown in the figure. Now let us discuss all security services one by one. Let us take up authentication. The authentication service is concerned with assuring that a communication is authentic. In the case of a single message such as a warning or alarm signal, the function of the authentication service is to assure the recipient that the message is from the source that it claims to be from. In the case of an ongoing interaction such as the connection of a terminal to a host, two aspects are involved. First, at the time of connection initiation, the service assures that the two entities are authentic, that is, that each is the entity that it claims to be. Second, the service must assure that the connection is not interfered with in such a way that a third party can masquerade as one of the two legitimate parties for the purpose of unauthorized transmission or reception. Authentication can be achieved by using message authentication code, digital signatures and challenge response techniques. Message authentication code, or commonly known as MAC, provides message integrity and message authentication using a combination of a hash function and a secret key. Sender uses a hash function to create a MAC from the concatenation of the key and the message. Sender sends the message and the MAC to receiver over the insecure channel. Receiver separates the message from the MAC. He then makes a new MAC or message authentication code from the concatenation of the message and the secret key. Receiver then compares the newly created MAC with the one received. If the two MACs match, the message is authentic and has not been modified by an adversary. Note that there is no need to use two channels in this case. Both message and the MAC can be sent on the same insecure channel. Intruder can see the message but can't forge a new message to replace it because intruder does not possess the secret key between sender and receiver. Intruder is unable to create the same MAC as sender did. The process is shown in the figure. Second technique for authentication is digital signature. Digital signature uses a pair of private public keys. I hope you are familiar with the concept of a signature. A person signs a document to show that it is originated from him or her or was approved by him or her. The signature is a proof to the recipient that the document comes from the correct entity. When a customer signs a check, the bank needs to be sure that the check is issued by the customer and nobody else. In other words, a signature on a document, when verified, is a sign of authentication. The document is authentic. When sender sends a message to receiver, receiver needs to check the authenticity of the sender. She needs to be sure that the message comes from intended sender and not from intruder. Receiver can ask sender to sign the message electronically. In other words, an electronic signature can provide the authenticity of the sender of the message. We refer to this type of signature as a digital signature, as shown in the figure. Sender sends the message along with digital signature, which has been created using sender's private key. The signature is verified at the receiver and using sender's public key. Another technique for authentication is challenge response. In password authentication, the claimant proves her identity by demonstrating that he or she knows the secret, the password. However, when the claimant sends the secret, it is susceptible to interception by the adversary. In challenge response authentication, the claimant proves that she knows a secret without sending it. In other words, the claimant does not send the secret to the verifier. The verifier either has it or finds it. The challenge is a time varying value such as a random number or a timestamp that is sent by the verifier. The claimant applies a function to the challenge and sends the result called a response to the verifier. The response shows that claimant knows the secret. Second major type of security service is access control. In the context of network security, access control is the ability to limit and control the access to the host system and applications via communication links. To achieve this, each entity trying to gain access must first be identified or authenticated so that access rights can be tailored to the individual. In simple words, we can say that prevention of unauthorized use of a resource, that is, this service control who can have access to a resource, under what condition access can occur, or what actions are permitted on the resource. Access controls can be mandatory, non-discretionary, or discretionary. Mandatory access controls use data classification schemes. They give users and data owners limited control over access to information resources. In a data classification scheme, each collection of information is rated and each user is rated to specify the level of information that user may access. These ratings are often referred to as sensitivity levels and they indicate the level of confidentiality the information requires. The level of authorization may vary between levels. Depending on the classification authorizations individuals possess for each group of information or resources. Non-discretionary controls are a strictly enforced version of mandatory access controls that are managed by a central authority in the organization and can be based on an individual's role, that is role based controls, or a specified set of task based controls. Role based controls are tied to the role a user performs in an organization, and task based controls are tied to a particular assignment or responsibility given to the individual. The role and task controls make it easier to maintain the controls and restrictions associated with a particular role or task, especially if the individual performing the role or task changes often. Instead of constantly assigning and revoking the privileges of individuals who come and go, the administrator simply assigns the associated access rights to the role or task, and then whenever individuals are associated with that role or task, they automatically receive the corresponding access. When their turns are over, they are removed from the role or task and access is revoked. Now let's move on to discretionary access control. These are implemented at the discretion or option of the data user. The ability to share resources in a peer-to-peer configuration allows user to control and possibly provide access to information or resources at their disposal. The user can allow general unrestricted access, or they can allow specific individuals or set of individuals to access these resources. For example, a user has a hard drive containing the information to be shared with office co-workers. This user can elect to allow access to specific individuals by providing access by name in the share control function. Next security service to be considered is data confidentiality. Confidentiality is the protection of transmitted data from passive attacks. With respect to the content of a data transmission, several levels of protection can be identified. The broadest service protects all user data transmitted between two users over a period of time. For example, when a TCP connection is set up between two systems, this broad protection prevents the release of any user data transmitted over the TCP connection. Narrower form of this service can also be defined, including the protection of a single message or even specific fields within a message. These refinements are less useful than the broad approach and may even be more complex and expensive to implement. The other aspect of confidentiality is the protection of traffic flow from the analysis. This requires that an attacker should not be able to observe the source and destination, frequency, length, or other characteristics of the traffic on a communication facility. The confidentiality can be maintained by using encryption algorithms. Let's move on to next security service, which is data integrity. The assurance that data received are exactly as sent by an authorized entity, that is, contains no modification, insertion, deletion, or replay, is known as data integrity. There are 5 techniques for preserving data integrity. Connection integrity with recovery. It provides for the integrity of all user data on a connection and detects any modification, insertion, deletion, or replay of any data within an entire data sequence with recovery attempt. Second technique for preserving data integrity is connection integrity without recovery. It works similar to connection integrity with recovery, except that it provides only detection without recovery. Third technique is selective field connection integrity. It provides integrity of selected fields within the user data of a data block transferred over a connection and takes the form of determination of whether the selected fields have been modified, inserted, deleted, or replayed. Fourth technique is connectionless integrity. It maintains integrity of a single connectionless data block and may take the form of detection of data modifications. Additionally, a limited form of replay detection may be provided. Finally, selective field connectionless integrity maintains integrity of selected fields within a single connectionless data block, takes the form of determination of whether the selected fields have been modified. One way to preserve the integrity of a document is through the use of fingerprint. If sender needs to be sure that the contents of his or her document will not be changed, he or she can put his or her fingerprints at the bottom of document. Attacker cannot modify the content of this document or create a false document because he or she cannot forge sender's fingerprint. To ensure that the document has not been changed, sender's fingerprint on the document can be compared to sender's fingerprint on the file. If they are not the same, the document is not from intended sender. The electronic equivalent of the document and fingerprint pair is the message and digest pair. To preserve the integrity of a message, the message is passed through an algorithm called a cryptographic hash function. The function creates a compressed image of the message called a digest that can be used like a fingerprint. To check the integrity of a message or document, receiver runs the cryptographic hash function again and compares the new digest with the previous one. If both are same, receiver is sure that original message has not been changed. Last security service which we will discuss in brief is non-repudiation. It provides protection against denial by one of the entities involved in a communication of having participated in all or part of the communication. It is broadly classified into two types. First is non-repudiation origin, proof that the message was sent by the specified party, and non-repudiation destination, proof that the message was received by the specified party. So, eventually we can say, because information and communication system carrying very crucial data and there are so many threats that can steal or modify data, the security of these information system becomes very crucial. We can protect information system by using different security services which include authentication, access control, data integrity, data confidentiality and non-repudiation techniques. Moreover, we can protect our computer system by using antivirus, host-based firewalls, host-based intrusion detection systems, and by applying host hardening methods. That's all for this session. Thank you for watching.